Welcome to The Explainer. You ever face a choice where one option is cheaper right now, but another one feels like it might save you more money down the road? Well, today we're going to break down the exact financial framework that helps big companies, and really even you, figure out what something truly costs over its entire life. And to get our heads around this, we're going to jump into a real-world, multi-million-dollar decision a company had to make. And what's so fascinating here is how the right answer can completely change depending on the questions you ask. So let's meet our company for this story, Angular Enterprises. They're a brand new semiconductor manufacturer. And to make their microchips, they need a huge, constant supply of ultra-pure water. They've narrowed it down to two very different options. Okay, here's the initial breakdown. Right off the bat, you can see the seawater option is cheaper up front. That's the first cost of 20 million bucks. But then look at the annual operating cost. The groundwater option is actually cheaper to run every single year. Oh, and that last line, salvage value, that's just the cash they figure they can get back by selling off the used equipment after 10 years. Think of it as a little credit at the very end. So you see the problem, right? It all boils down to this. Do you pay less now with the seawater system, or do you pay less over time with the groundwater system? How in the world do you compare these when the money is leaving your bank account at totally different times? Well, to solve this puzzle, we need a way to pull all those future costs into the present day. And lucky for us, there's a financial tool designed for exactly this. It lets us make a true apples-to-apples comparison. It's a concept called present worth, or PW, and you can just think of it like a time machine for money. It tells you what a future cost is actually worth in today's dollars. The whole idea here is that a dollar today is worth more than a dollar tomorrow, because, you can invest it and make more money with it. Let's make this super real. Imagine you have a guaranteed $1 million bill that's due in exactly 10 years. Well, if you use a 12% annual discount rate, which is basically the return you could be earning on your money, that $1 million problem in the future is only worth about $322,000 in today's money. That's the core idea we're going to run with. All right, let's take this present worth logic and apply it back to Angular's big choice. We're going to assume both systems last for 10 years, and we'll use that same 12% rate to bring all those future costs back to today. So when we crunch all the numbers, taking every single cost over the next decade and translating it to today's money, we get our first answer. As you can see, the total lifetime cost of the seawater system in today's dollars is about $30.6 million. The groundwater system, it's more expensive, coming in at over $33 million. So there you have it. Based on these numbers, the seawater system is the cheaper choice by about $2.5 million in today's money. It's a no-brainer. Case closed, right? Well, not so fast, because in the real world, just one tiny new piece of information can change absolutely everything. Here's the twist. It turns out that seawater is way more corrosive than groundwater. And what that means is the equipment for the seawater system isn't going to last for 10 years. Nope, its real lifespan is only 5 years. And this just throws a huge wrench in the works. You can't just compare a 5-year system to a 10-year one. It's not fair. It actually violates a key rule of this kind of analysis called the equal service requirement. But there's a workaround. The seawater system can be totally refurbished for $10 million at that 5-year mark, which would extend its life to the full 10 years. So how do we make this a fair fight again? Well, there are two standard ways to handle projects that have different lifespans to make sure we're getting that equal service. The first way is to look at the long haul. It's called the least common multiple method. For us, that's 10 years. We'll factor in that $10 million refurbishment for the seawater system. The second way is more of a sprint. We use a study period. We can just set a fixed window, say 5 years, and completely ignore any costs that happen after that date. And check this out. When we analyze this over the full 10 years, the decision completely flips on its head. That $10 million refurbishment in the future, even when we discount it back to its present value, makes the seawater system's total cost shoot up to over $36 million. All of a sudden, groundwater is the cheaper option by a lot. But hold on, what if Angular only really cares about the next 5 years? If we use that 5-year study period, the decision flips right back, because now that super expensive refurbishment falls outside our analysis window. So the seawater system is once again the winner. And this right here is the most important takeaway of all. The math itself isn't the answer. The calculation is just a tool. The real decision happens when you choose your assumptions, especially your time frame.
So this gives us a simple but really powerful 4-step playbook. Step 1, frame your options. Step 2, you have to consciously define your time frame. Is this a short-term play or a long-term investment? Step 3, run the numbers using present worth. And then step 4, make the call that actually lines up with the horizon you picked.
And that's really the magic of this method. It's so popular because it cuts through all of the noise of future payments and complicated costs. It just gives you one single comparable number for each option right now. It forces you to be clear about what really matters to you. So the next time you're facing a big choice with costs that stretch out over time, don't just get blinded by today's sticker price. Ask yourself, what's my real decision-making horizon? Because the right choice for the next 5 years might be the totally wrong one for the next 50. What's the real cost over the entire lifetime of your decision?